Welcome to our Sports Engineering Project 2, exploring different levels of fruit protection. All data and analysis was done by Cleo, Anna, Kaylee, Christine, and Matt. For our experiment, a 1-pound, 24-inch circumference blue bike helmet was used. The helmet was purchased directly from the online retailer Amazon and is composed of an outer ABS plastic shell and an inner 1-inch thick, stiff styrofoam padding. For each trial, the cantaloupe was dropped from the second story of the north parking garage on the University of Connecticut's campus at a height of 25 feet. For each trial, group member Cleo Alberts held the fruit outwards at a repeatable, straight length and dropped the fruit by releasing it with her hands in the most similar manner possible each time. For the purposes of this project, we will examine 3 different protective layers through an iterative design process to show increased optimal helmet protection. For the first trial, the cantaloupe was released with no protection to demonstrate the full impact of the concrete on the cantaloupe and to confirm that it was being dropped from a height that required protection to remain undamaged. When dropped without any protection, the cantaloupe completely broke open and smashed, confirming the team's prediction that the height in which we were using to drop the fruit was sufficient enough to reflect destroying, bruising, and protecting the fruit. The team added an additional padding in the form of 1/2-inch to 1.5-inch thick polyurethane cushioning foam. Our second trial consisted of a cantaloupe protected inside the blue bike helmet with a hard ABS plastic outer shell, 1-inch hard EBS styrofoam already provided by the helmet design, and a 1/2-inch thick polyurethane foam layer. Our intention was to provide a minimal use of protective material. The goal was to damage the object enough to create a qualifiable bruise, but not so much as to destroy the cantaloupe completely. The results from this second trial showed that when the cantaloupe was dropped with the 1/2-inch thick polyurethane foam layer, it produced a hairline crack along the outer edge. This was confirmation that the cantaloupe had been bruised but not broken. The third modification the team made to protect the cantaloupe was to increase the amount of polyurethane foam to 1.5 inches total. In this trial, there was no wiggle room or additional space between the cantaloupe and the helmet. The fit was very secure, and the cantaloupe was difficult to remove post-drop. This was the optimal use of protective materials so that there was no damage done to the cantaloupe. This concludes our experimental trials and results. Thank you.